I really have come to learn something. This class took me 4
Yep.
years, and I've really learned that C is probably the single most important programming language that anyone will ever learn, and it is the programming language that no one should ever use. Once you learn to program, you probably need to spend a little time figuring out how programs code really works. And if you go and use Django or you do databases or some other thing, you kind of move away from the purity of what programming really is. But secretly, what I wanted to do is I wanted to take code that was written by ChatGPT and put it in this production software. I'm like, because I wanted to say, like, I want ChatGPT to be a partial author of my software. So I didn't want to look too close at it. I just wanted, because I tested out just fine, right?
That's the worry. That's the worry, yeah. Hey everyone, it's David Bombal back with the amazing Dr. Chuck. Dr. Chuck, welcome.
It's great to be here, David. I've been looking forward to this for as long as since we did our last recording, last interview, because I've been building this course for 4 years and I'm looking forward to updating you on it.
Yeah, you got to tell us about this because this is really exciting. I believe I've heard you say this is about the best programming language, right?
Well, I'm not sure about that. I think that what this is about the programming language that you should never write any code in, unless you're writing some weird microcontroller or something. I really have come to learn something. This class took me 4 years, and I've really learned that C is probably the single most important programming language that anyone will ever learn, and it is the programming language that no one should ever use. And so that's kind of an interesting irony, because I have been thinking a lot about the difference between a junior programmer who can kind of cut and paste things and fix syntax errors, and a senior programmer who can see sort of through the mists and see what's really going on and be that senior developer. And when there's a problem or when there's a performance problem, they sort of have a sixth sense that allows them to see inside what's going on beyond just, I wrote this code and it seems to work, and yet. So I keep thinking that this course is the step from junior programmer to senior programmer, and the C programming language is the thing we all fall back on as senior developers, whether we know it or not.
I like the differentiation you made. You said it's the most important language, not the term I use the best, but most important, but something you shouldn't use. Can you explain what you mean by that?
Well, it's the most important because of the understanding bit that I just got done talking about, but it's something you shouldn't use because it's just a dangerous programming language, right? Everything is a pointer. You can mess up pointers. You can over-reference pointers. You can mess up your stack. I mean, if you go back literally for the past 25 years, every single significant security failure in operating systems and softwares is almost always related to the C programming language, like Heartbleed. If you go all the way back to Heartbleed, that's a long time ago. That was code in C, okay? And, it's just when you write in C, you have to be super disciplined. You have to have code review. And even when you do that, something will get through. It's just really dangerous to write professionally in C and then put that out there for the world to see. I'm sure parts of the Cisco kernel are written in C, and that's okay because people aren't hacking it and attacking it. If you build a website and it's written in C, or you build SSL and it's written in C, that's dangerous.
Yeah, but it's interesting because I think we discussed it last time. And just for everyone who's watching, I'll link previous videos below. You said that the successor perhaps to C might be Rust.
Yeah, although that was some time ago we talked about Rust, and Rust hasn't shown up in my feed much. It doesn't seem all that likely to becoming the successor. And I've got some comments from people that talked on our last conversation whether or not Rust was the next thing. And I think what had happened was I had guessed that Rust, instead of investigating Rust, I imagined what Rust would be if I wrote it. And I'm like, if I wrote Rust, if I designed Rust, it'd be awesome. But unfortunately, Rust was not built by me. And so it still has a number of the flaws of C still in it. And so if it has the flaws of C, but it's got some modern affordances, like what exactly is the point? I mean, somewhere between C and Python, what's there? Because it still doesn't make it easy to do certain things. And it's kind of like a little bit better C, but then why? So I think the jury on Rust is going to stay out. I just don't see that it adds all that much above C, and it doesn't necessarily solve all the problems of C. If it was like a real safe C, I could get behind that, but it's not.
So just, I need to emphasize this just for everyone who's watching. Dr. Chuck, the reason why we're having this conversation is you provide amazing resources for people around the world. So I think we need to emphasize that the reason we're having this talk is you've released a new C course that people can access for free. Is that correct?
That is correct. It's called C Programming for Everybody. It's out on Coursera, and it is available for free on www.ccfree.com.
Is this based on the previous conversation we had was that very famous book that you love, in the 1978 C book? Is that correct? I'm glad you brought it. There you go.
I brought it. So yeah, it is based on that. And so because the idea of C Programming for Everybody is not that you're going to write code and be a professional C programmer. C is a foundational notion of technology. It is the moment in 1978 where software portability became feasible and practical, irrespective of the underlying hardware. And so if you look at everything up to 1978, we were using languages like Fortran or COBOL. And if you had a CDC computer, you wrote your stuff in Fortran. System stuff, non-system stuff. If you had a Burroughs computer, you wrote your stuff in COBOL. And the COBOL on Burroughs computers was super fast. And so the idea is you go from one computer to the other, but you just have to completely change everything. All new operating systems, all new languages, all new library sets. And C was research, inadvertent research into how to build one operating system, Unix, one programming language, C, and then have that work on virtually any piece of hardware that you would come across. And part of it was because the people at Bell Labs in New Jersey were given a bunch of hand-me-down crappy computers. They didn't have a lot of money, so they had to build an operating system and a language for hand-me-down crappy previous generation or 2 generations back computers. They had to make something work on them, but then they would get one hand-me-down this year, and then they get a different hand-me-down next year and a different hand-me-down next, and then we'd have 12 hand-me-downs from this other thing that they were going to try to do something. So they had to come up with a way to get in a working environment that let them get work done, and yet was independent of the hardware that they were just being given as hand-me-downs. And so this book, the 78 edition, which is becoming ever so rare, that book is this...
Because of an interview. Sorry, go on.
It did. As a matter of fact, after the last interview, that price of that book spiked up to over $100. It's somewhere between $25 and $75 right now. This book is written in a style of a research paper, like a research report from an environment. It's like, well, we were trying this and we tried that and this other thing worked and this worked pretty well. And we had 2 ways of doing this and this is the one thing. And so these authors in this book break the fourth wall all the time. They just aren't telling you, here's the programming language C and here's where you put the semicolon. No, they're saying like, here's what we were thinking and all the 2 things that didn't work out so well, but we figured it out afterwards. And so the 1984 edition of that book, which I actually don't have a copy of the 1984 edition, took all that out because by 1984, the language was just like, of course, C. What else would you ever do? And so what I like is the notion that C has laid the groundwork for modern software portability, and the book was written before it was an assured thing. And so that's what I find super delightful about it. And you're reading the book and you're saying, well, how come this is such a hard problem? The answer is because these are the people that made it possible to solve the hard problem. And so you have to read it. You go back in time and you read it and you're like, everything was difficult in 1978. Nothing was easy.
Yep.
And this book was showing you ways to make it easier. And that to me is the most important thing. It's like the movie Somewhere in Time, where you just go back in time and you kind of live in a different time and enjoy that different time. And then you come back to the present and you don't have to write the code in this language. So that's the fun part of going back in time, learning a language with wearing an old hat from 1978, right? So I'm going to wear an old hat while I take this course, and then you come back and you're in the modern world again, and you have Python, and you have dynamic memory, and you have more than 640K of RAM, and all these kinds of things that make life wonderful.
So, Dr. Chuck, some questions that people might have about the course. Should I take C as my first programming language?
Absolutely not. The key thing is C. Learning C is the way that you learn about that first programming language. And these days, Python is pretty much the standard first programming language. It doesn't waste your time. There's no details like stack frames or pointers or anything like that in Python. And you can go to work with Python. You can work in artificial intelligence. You can work with data mining. You can work on all kinds of web development, all kinds of things in Python. And so it's foolish not to take Python as a first language. And of course, I teach Python for Everybody, which is the world's largest and most successful Python programming course. 3 million around the world have taken that course. And so that's the first course, no question. The interesting thing, and we talked before, I am increasingly starting to think that C should be the second programming language.
Oh, that's interesting.
I know. When we talked 2 years ago, I thought that C should be like the fourth or fifth thing that you learn.
Yeah.
And the reason for that is that once you learn to program, you probably need to spend a little time figuring out how programs code really works. And if you go and use Django or you do databases or some other thing, you kind of move away from the purity of what programming really is. And so this course, C Programming for Everybody, turned out so well. And I didn't know how advanced it was going to be. As a matter of fact, I spent 4 years working on this class. And you and I think, talked 2 years ago. And
Amazing.
I was kind of halfway through that. Halfway through. It takes me a long time to build new classes because, there's a lot to it. And so what I've kind of learned in the past 4 years of building this course is the most difficult concept in all of programming is object-oriented programming. It absolutely is. And I think that most Python courses, most C courses, most C++ courses, and literally most Java courses do an awful job of teaching object-oriented programming. And that's because they say, well, we're going to make an animal, and then we'll make a cat that inherits from animal, and then we're going to make a dog that inherits from animal, and we're going to make the cat meow and the dog bark. Now, object-oriented programming, and if you ever are a professional programmer, it is not about animals, cats, and dogs. It's about solving problems of isolating code without, and implementing things and changing implementations. And there's so much to it that understanding object-oriented programming is, to me, the key to becoming a successful professional programmer. And so this course, the C course, when we talked last time, I didn't think I was going to talk about object-oriented programming in this C course. As a matter of fact, I had this whole story arc, and I think of courses as stories. I had this whole story arc where at the end, I'm like, and I'm not going to talk about object-oriented programming. And I had these two poems I read at the end. And one was Miles to Go Before We Sleep. Both were from Robert Frost. In a Forest Dark and Deep, Miles to Go Before We Sleep, Snow is Falling, all that stuff. And I had another one that says, I'm going to take the road less traveled. And the idea that I had when I was reading the poem, The Road Less Traveled, was I'm not going to teach you object-oriented programming. And most people at this point in the class teach you object-oriented programming. So I had all these lectures recorded with these two poems in them at the very end of the class. And what happened was I was teaching the class live, because I did that a year ago. I was teaching it on campus live. And I'm like, I had a bunch of really sharp students from courses. I only had 12 students, so I could talk to them continuously. And I said, okay, we're done now. And they're like, you're done? I'm like, yeah, road less traveled. We're not going to go that way. And they're like, you can't do that. You have to tell us about objects, and you have to tell us about C++. I'm like, no, but I don't like C++. And they're like, yeah, but we like C++. And so I had to go back first and edit the poems. Now there's only one poem in the thing, and that is Miles to Go Before We Sleep. And then what I decided to do was focus the last third of the class, which, as of this time last year, didn't even exist, on implementing object-oriented programming in C. And so what I began to do is I said, let's just say you're at C and you're in 1978 and you're looking forward and you think object-oriented programming is cool. How would you build C++ if you were in C? And then how would you build Python and the object orientation of Python if you were in C? And this turned out to be great. I mean, all of a sudden this like giant road opened up in front of me. And the last few parts of the class are literally implementing dictionary, string, and list, the core data structures of Python. And so we look at Python code, and then we implement in C the kinds of things under the covers to implement the list object, the string object, and the dictionary object. And then the way the course ends, the C course ends, is we literally do, as the last exercise of the course, the first exercise of my Python course, except that we do it in C. And so it's this beautiful kind of like, whoa, what a beautiful story. I mean, again, I think of this as a storytelling, not as like, learn this, learn that, but it's this beautiful story. Now, one of the things that's happened since we last talked, I don't know if we talked since I interviewed Brian Kernighan, the guy who wrote the book. Did we talk about that?
No, no, we haven't. No, you said you were going to talk to him at some point. That was where we ended it last time.
Well, I mean, start that story a little bit earlier, right? So there's this book from 1978 that you cannot buy. It's not available online. So part of the reason it took me 4 years to make it is the first 2 years, I basically stole the book. I bought a bunch of used copies of the book. I cut off a spine of the best one. I digitized it at high level, and I OCR'd it. And then I put all that stuff in GitHub, and I hired a bunch of graduate students to go over line by line, fix every single thing to make a cool online version of this. And I made all the code executable, and I made all this stuff, and I built this book without ever knowing if I was going to get in trouble. And so a large part of the 4 years was talking to lawyers to see, am I going to get in trouble for what I just did? I just had to do it because it's just like I love this book so much. So
yeah, but there was a good reason. The book is out of print; it's not available,
it's not
there's like a licensing thing. You were thinking about using it, right?
Yeah. And the lawyers told me there's a thing called fair use, right? It's academic purposes. It's a historical thing. So lawyers felt like I had a pretty good chance, right? It was enough of a good chance for me to go forward. So I built this perfect, beautiful digital copy of the book. And right before we were going to start the process to convert it to go on Coursera, I thought to myself that I better send a note. This is December last year, 12 months ago. I better send a note to Brian Kernighan, because even though my lawyers said that we would fight them and I had a good case, I did not want to offend someone who I considered like a god, right, in computer science. So I sent a note December of last year. December 2 years ago, December 22. I said, Brian, I made this book and I hope you like it. And I didn't hear from him for a couple of weeks. And then he said, that's interesting. I have included on this email the editor of that book from Pearson. And so I'm like, oh boy. And so I replied to the email and I sent a note to Gary, the fellow at Pearson. I said, Gary, I love this book. It's a great book. I'm using it under fair use. I think it's a good thing and people are going to love it. And I love the 1978 edition. And Gary said, could we get together on a Zoom call? And I'm like, oh, damn, that is not going to go well at all. So Gary, I'm just like I thought, should I call the university lawyers and tell them I'm going to get on a Zoom call with Pearson? Should I call my own lawyers? Should I do whatever? I thought about it for a very long time. I finally say, you know what? I think I'm just going to go alone on this particular one. And I'm going to schedule a call with Gary, the Pearson editor of the book. So I get on the call with Pearson, and there's one other guy. And the guy looks like me. He's like old, goatee, white, gray hair. And he says, the first thing out of his mouth is like, man, I love what you did with the book. I'm like, oh, okay, this is not going to be so bad. This is not going to be so bad. Great. And then the next thing he said is, could I have a copy of it? I'm like, what?
Wow.
I'm like, of course you can have a copy of it. So it turns out that they have been resurrecting old books. And what I had done in creating, in effect, a pristine, perfect digital copy of an old book that literally was only on paper. They're like,
oh, wow.
We have this online service, and if we could get our hands on your book, we could put that into our online service. And I'm like, boy, that's not how I thought this conversation was going to go at all. And so I've had an ongoing conversation with Pearson. Once Pearson and I were friendly, I sent a note to Brian Kernighan and said, could I come to Princeton and bring my camera gear and interview you? And so I did. I flew out to Princeton February 2023, and we started doing an interview. And some of my interviews I'm very ready for, and some of them I'm not well prepared for. I thought this one was so easy that I would be super well prepared for. I wasn't. I literally wasn't well prepared for an interview of Brian Kernighan, a person who I thought that I knew. I'd watched YouTube videos of him. So the first thing you know about Brian Kernighan is he didn't really invent C. Brian Kernighan was the guy who wrote all the books. And so if you look at the co-author, Kernighan and Ritchie is the one that built C, and Kernighan's like, hey, can I write your stuff down and just get it out as a textbook? Ritchie's like, yeah, I don't care. Do whatever you want. So Kernighan was a leader, and he was an important fellow. He even wrote like a memoir, his own Unix memoir. This one I got signed by him. And he was like a leader at Bell Labs. He was like a boss at Bell Labs. And so I started asking him questions, and I was like, what was it like to invent C? He's like, I didn't invent C. It's like, oh boy. But then he was kind, and he told me a bunch of really good stories. And then at one point, we started talking about C++. And I want to give your viewers a poll. And that is, from like 1980 to 1984, Bjarne Stroustrup, the inventor of C++, was working on C++. The question is, what country was Bjarne Stroustrup working in when he was building and evolving C++? We'll just kind of, okay. So let's do
Should we get in the comments?
We can let them go in the comments. But so let me give you some choices. A, Norway. B, Finland. C, Denmark. D, UK. E, United States of America. So
I don't know the answer.
Well, so if you know, he's European. He sounds European, looks European. I've got an interview of him, and I think he went to the university in Denmark. Well, the answer to the question, hopefully by now you've all figured this out, is E, United States of America, not just United States of America. Bjarne Stroustrup, the inventor of C, graduated with his PhD from whatever university and was hired by AT&T Bell Labs in Murray Hill, New Jersey. And so Bjarne Stroustrup was working on C++ 2 doors down from Dennis Ritchie working on C. I mean, seriously.
Oh, wow.
And so you look at the evolution of C from 1978, 79 through 84, C++ was in the building, co-evolving it, things like the void type, etc. And I'm like, holy crap. And then I had to redo the course again because I always thought that C++ was kind of like an annoyance, right? It was like, oh, there's C and then there's this weirdo European C++ thing. Not at all. C++ was core to its development. And as Brian tells in his interviews, like, oh yeah, we loved him because his C++ code generates such weird C code that it broke everything you could possibly break in C, and it helped us fix C. And so then you see this coevolution of C and C++ in the early 1980s. And so the next interview that I don't have scheduled yet, but I've got agreed to, is with Guido van Rossum. And once I realized that the C and the C++ were one concept, right? They were not like a weird add-on. I'm like, now that I've done all this study of how you would build Python in C, I'm like, I wonder if Guido van Rossum has a weird connection. And he wasn't just a weird guy from the Netherlands, right? Just a random weird guy. And we have this cover story on Python that was, for children and da-da-da-da-da-da. I think, and we'll see when I get that interview, I think that what we're going to find is that Guido van Rossum in the 80s was going through the exact same thing that I'm going through in the last half of this course and saying, what's the best way to use C? And I think if you look at the patterns over and over and over again in Python, you see that there are imitations of how C++ did it. But I think Guido was doing C++ 1 better. I think Guido looked at C++ and said, no, you don't quite have it right. I'm going to build this language that's kind of a demonstrator of what C++ should be. And I'm going to advance the actual research of what object-oriented programming is forwards, because I don't think C++ does a good job. I'm putting words into his mouth, and I hope he doesn't see this before this interview, right? But that's right now, that's my hypothesis as to how it worked, that he wasn't just making an easy to program language. He was also trying to create a stellar, absolute, perfect, best practice for what object-oriented programming meant by creating all these things. And what's cool in C programming for everybody is if that's the path he took, the last part of this course goes right down that path. And you see just how beautiful and elegant it is. And then you see things like how the dictionary has evolved from Python 2 to Python 3 to Python 3.6 to Python 3.7 and on and on. And then it turns out that that's just the natural thing you do as you start to build all these objects in C. And so we build a hash, which is what Python 2's all the way up to Python 3.6. It was a hash, not a, then we do a tree map, and we do all these little things, and we do multiple data structures and layering like a linked list and a hash map on top of each other, and then a linked tree. And you're just like, I think this is exactly what Guido van Rossum was doing and thinking as he was building Python. And if that's then the case, right? If Guido van Rossum was really trying to finish the research work that was started in C with Kernighan and C++ with Bjarne Stroustrup, if Guido was really like, I'm going to finish this work that you all have started, I think it's a beautiful, beautiful concept. And back to what I think was your first question is like, that tells me that the right thing to do is to learn Python and then learn C to get back to Python. And then you have this like complete readiness for object-oriented programming. And then you take like a Django class, and I talk about object-oriented programming in Django class, and you're like, no, I get that. I know what that means. And that's what senior programmers need to have, that capability, so that when they're taking a Java class and I say object blah, 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 they're there, or JavaScript object blah, 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 and they're there. So it is quite a journey. And, because there is no textbook for what I'm doing, because I'm really thinking this as research and a historical curiosity. I mean, I got to go where the story, I'm more of a documentary filmmaker than I am a book writer, right? I think of this as like I run around with my backpack with a bunch of cameras, do documentaries all over the place, and then make a story from the documentaries. And so I just hope that people see this course as it is not just another C course that just teaches from a random book. This is like the history of computing, object orientation technologies we know it.
Because I'm a bit slow. Python's written in C, is that correct?
Yes, the main Python that we use is called C Python.
And that's the whole point of what you said, right?
Exactly.
Sorry, go.
Now, there's other Pythons that are written in implemented in other language, but when Guido started, it was in C, and then by far the most popular Python implementation is called C Python. And you can look at the source code, and you can see what's in the current Python today that makes dictionaries work, and you can kind of, if you know C, you can look through that code.
And that's what you're doing in your course. Is that right?
A little bit. I mean, what I'm really doing is I'm writing simpler versions of what it would be, so that, it's like, that'd be like in the first couple of weeks when Guido was writing Python 1.0 back in 87 or whenever it was, I'm writing the code that he was writing on Christmas that year, which is I'm going to write a string class. And it's crude, but at least it proves that I can write a string class and I can make it really easy to use and, safe, no pointer problems, no security problems, on and on and on. So
you're basically writing Python in C. Kind of the same thing. Is that kind of right?
Right. Not so much the language, but the libraries, right? The objects that you're using in Python.
That's lovely. So, I mean, I think that's a great explanation. So that's why the full circle is there.
Right.
So you start with Python, go to C, and you're back into Python because you're basically writing Python.
Exactly. Now for the rest of your career, you can write Python or JavaScript or Java the rest of your career and not worry about C. But C is make it so that you're not unsure of what it is that you're doing as you're writing in all those other languages. You are sure of what's going on.
This is quite a change from what we spoke about last time. And
it was.
Perhaps you can just revisit it for people who haven't seen it, our previous videos, because you got the master programmer. And if you can just explain that concept, and then I've got it written here, like 10 courses that we mentioned last time. It was Python, Django, PHP, and then SQL, and then C. But you've changed that.
I have changed that, right? And so the path to the master programmer in short is the idea that I want to create a set of courses that when a student completes those courses, I'm willing to hire them. So I've got a whole bunch of courses, Python, Django, PHP, as you mentioned, SQL, and now C. And I thought that C was like the beginning of the more advanced phase of this master programmer, but now I kind of think it's the second class in the path to the master programmer. And then you take like a class like Django and you're like, whoa, object-oriented, I get it. So all of a sudden, everything you're doing in Django, you're doing it from a much stronger position. And so it's not that I don't like any of those courses that I have, and they're still in the path to the master programmer. But the C class is the second class in the path to the master programmer, when originally I thought it was going to be the fifth class. And the ironic thing is I'm kind of following the path computer science does. A lot of computer science schools teach.
That's ironic.
It is ironic. They teach Python first and C second, although they tend to teach C++ second, which I think is a mistake. But I do think that what I'm doing articulates really well with computer science, in that my Python course is not really recognizable as the first computer science Python course, and my C course is not really recognizable as the first computer science C course. And so if you're going to go and get a computer science degree, people should take my Python course, and then they should take my C course, and then they should go take a computer science degree, right? Because the way they're going to teach you C and C++ and Python and computer science is rigorous. They're really teaching you like the language, how to change spark plugs. I'm teaching the feeling of all these things. I'm teaching the kind of the gestalt of what Python is from a gestalt perspective, what C is from a gestalt perspective. And I'm preparing you very, very well for a rigorous treatment of Python, C, and C++, so that you will crush those courses. So a big part of computer science is people walk into these courses and they're not really ready for them. And so I think that people should take Python for everybody and C programming for everybody in high school, so that when they go get a computer science degree, they're actually successful and they love it from end to end, as compared to they're miserable. They can't figure it out. They don't actually learn anything. And 2 years later, they drop out and quit. So for me, these are pre-computer science classes. These are not replacements. And even even the object-oriented stuff I'm doing at the end to C Programming for Everybody, it's not as strict and rigorous as the typical computer science class that's going to teach trees and maps. They're going to make a lot harder class, but they're not going to care about the feeling of what it means to be a hash map and what Gita was thinking when he was building one of these things. And so that's the path to the master programmer. I really only have, at this point in my mind, 2 more classes to the path of the master programmer, although there could be a 3rd class. Yeah, I mean, you know me, I change my mind all the time. And once I teach things and I give them to students, students tell me I'm wrong and then I change. So the next course I'm going to build is computer hardware for everybody. I'm not going to computer architecture. I'm going to talk a little bit about machine language, assembly language. I'll talk a little bit about gates. And I found a book. And here's the book. It's called Computer Engineering for Babies. Okay.
Oh, and wow.
So if you hit this button, the light lights up.
Yep.
See that?
That's my level, yeah.
So this is a wire and the light lights up. That's a NOT gate. If you push it, it turns to 0.
That's good. That is very good.
This is an exclusive OR. If you push them both, it stays off. If you push either one, it stays on. So I found this book, Chase Roberts. Poor Chase Roberts is going to be featured on your podcast, and he's going to sell way more books than he ever thought he was going to sell. I'll probably warn him. That is how I teach hardware. I mean, I sent a note to this guy. I'm like, I love your book, and I want to write a second one. He wrote a second one. I didn't like his second book as well, but I want to write a second one about starting with gates and just... It's not that hard starting gates to learn a little bit, and then you talk a little machine language. So that I think that might not be, it's kind of like a 1-credit college class, kind of like a survey of computer architecture. And then I'm going to teach a Java class. But by the time I'm teaching a Java class, I'm going to teach you how to program like a professional, right? It's not just, I'll teach the programming language Java, and then I'll teach you how to program like a professional. And we'll start looking at really hard problems and that stuff. So I'm not that far away at this point from what I think of as the last master programmer class, to the point where I'm starting to produce people that I will hire at that point.
Yeah, because last time you had assembly. You still thinking of doing that?
Assembly is an architect. Computer architecture is hardware plus assembly. I've been thinking more about it, and now that the C class is done, I got so much done in that class, the hardware and assembly class is kind of going to collapse into one.
And then last time you had Rust and AWS, but like based on the sort of what you're seeing in the industry,
I don't see Rust as adding much value anymore at this point. I wish it had. I think there is a place for a language that has sort of like the low level expectations of C, but at the same time, there's a number of libraries that make it much safer to use. And that's the problem. Strings are not safe. I want safe strings. I want safe lists, and I want safe dictionaries. I mean, that's really what I want, is a C language that has Python-like underlying libraries.
Dr. Chuck, I just want to emphasize something. So to make sure that everyone understands this, you've got this path to master programmer, and all the content is freely available. Is that correct?
Yes, it is. Yes, it is. It's also available on Coursera, but it's also just available on websites that I have up. And you just go to, online.dr-chuck.com. And you see all of them. And when new ones come out, they'll be there as well. So I'm committed to making all my material as free as possible. I don't think that precludes people paying for content. When you pay for content, there's somebody that kind of certifies that you've done the work. It gives you a certificate. It's one thing for you to say that you took a course. It's another thing for somebody else to say that you took a course. And so things like certification, there's value in that, but it costs money to certify you. I mean, you can't just say, oh, yeah, I'll self-certify. Well, that doesn't say much. So, yeah. And so the idea is that I am really passionate about making software development as a career available to everyone, everywhere in the world, regardless of how much money they have and regardless of the kind of resources that they have to bring to bear. And I think our world will be a better place when we do that.
I love that, because, I mean, that's the thing. Some people can afford it and they can get the extras, but some people just can't afford anything. And this gives them the opportunity to change their lives. And I love what you're doing. I love that you're doing that. You said in our last interview something along the lines that $100 is a lot of money for a lot of the world.
Yes, absolutely. And I mean, I teach at the University of Michigan, and you would think that everyone who steps foot in the University of Michigan is, financially super solid. And then we post student jobs, and we get tons of applications. And you think, oh, well, isn't everybody rich? And the answer is no. It turns out even at a place like Michigan, where there's a lot of wealthy people going to school there are plenty of students that are not wealthy, and they're fighting semester to semester. And so if we think about these things as appealing to those with limited means, and not think of it as like, oh, this is a cool boot camp, and I'm going to charge somebody $20,000 for a month worth of stuff, and you're going to sit and learn Ruby on Rails for 12 hours a day. I mean, I find that really reprehensible that that's what people decide is the right thing, because there are people that can afford to pay for that. But I also think that those courses aren't all that useful, and the long-term benefit of a 2-month $20,000 boot camp is nowhere near as good as carefully taking a bunch of free course materials and really understanding what's going on in those courses and taking your time, and then growing your learning while you're going to work. Working and learning at the same time is way better than going to some boot camp and then walking out with a fresh load of stuff in your head that you think you're going to make money on, but then you don't get a job, and then it all goes away in another month. So
I'm glad you mentioned that, because you mentioned earlier that someone could take Python and C, and then they could go and do computer science. But let's say I don't want to go to university. I just want to get a job. Can I take this the roadmap to master programmer? And am I ready perhaps to get a job at that point?
Absolutely. So, and again, you need to have some breadth. You need to have some breadth so that when you walk into a job, chances are good that you're not going to do exactly what you were taught in college or in your boot camp. And so if you learn a bunch of different languages on the way to the master programmer, then when they say we're using Rust, we'd be like, oh yeah, okay, I kind of know C, and I kind of know Python, I know PHP, and I know Java. I'll figure Rust out, right? And so whatever it is, Scala, unfortunately, there's all these like languages of the moment that seem to be exciting, and they contribute something, but then they don't necessarily completely stick.
So if I'm starting out, first language to start with is Python, and then second language C.
Yep.
I just want to hammer home on the point. What I'm going to learn in C that I'm not learning in Python? Is it just a better understanding how programming works? Is it object-oriented programming? What am I getting that's the difference between those two? And why don't I just stick with Python perhaps?
Well, if you take a Python class, you can be employed. That's what I'll call a junior programmer, right? And there are lots of people that do pretty well as junior programmers, and they go to Stack Overflow and ChatGPT and paste a few things in and get the work done that day, and they move forward. But there comes this moment where you get stuck. If all you know is Python and all you've done is kind of basic Python stuff, you get stuck where you got to go find somebody senior, right? Someone who's done a lot more. And the question becomes, especially for companies, how do we get people from this sort of junior level to senior level? And we're pretty good at making junior level programmers these days with things like Coursera, et cetera. But then how do you make senior folks? And that is where the C class comes in. So one of the things I'm trying to convince companies who have found the Python class really useful is that the C class is even more useful, because it's going to take your current employees and it's going to up their game, and it's going to give them the necessary tools to kind of grow from junior to senior and go from just, you got a bunch of junior programmers and they're doing a bunch of stuff, but then you got all these senior people that kind of have to help them when they get stuck. Well, how do you make more people to help everybody when they get stuck? And that's where the C class comes in, is it's the ones where you're not afraid. And I guess, I'm not afraid of what programming is when I'm done with a C class. And that's one of the things I love about it. And that's one of the things I love about having a computer science degree is I'm just not afraid. Eventually I'll put enough print statements in it. Darn it, I'll figure it out. And I don't care what language it is. I don't care any of that stuff. And that's what I'm trying to create a course that can take you to that point where you're not afraid of the technology that you're using.
But I shouldn't use C in production because of all the vulnerabilities and issues with C, right?
No, and I sure hope you don't find a job where they tell you that your job is to write a whole bunch of C code, because that's really, really difficult and should be reserved for the most specialized of things. And these days, if you're going to do something super specialized, you might want to use C++, because the problems that you are going to need to solve in a sort of a highly, rigorous and scary environment, C++ is probably the better tool to see for that.
I'm glad you said that, because it was like, okay, so if I don't use C, what do I learn? Is it Rust? Is it C++? What do I learn next?
That's a good question. That's a good question. I'm looking at I tend not to do anything. I tend not to like teaching proprietary technologies. I tend to like teaching open source technologies. And if you look at the business world uses either open source stacks, which are like Python and Java, or they use proprietary stacks, which are like Windows, C# and Visual Basic. So you'll notice that I don't teach anything in the Windows C# Visual Basic world. C++ is a weird thing, right? I'm not sure that a lot of general purpose folks use C++ for building web servers. I know that Microsoft people use C# for building web servers, but I don't think open people, I think they tend to either build them in PHP, Python, or Java. And so what I've done is I've covered what I consider the essential languages on the open side of the house. I'm not pretending that I am a Microsoft certified software developer, right? Because those languages are completely different. There's equivalences, because C# is more like Java than it is like C++, even though it uses syntax that's C++ like. And so I'm not trying to sort of get into the business side, but a lot of places don't like using Microsoft Windows because of the continuous licensing problems that you have. And whereas if you're starting a really big company, the last thing you want to do is base it on a proprietary, pay per click kind of a thing. And so you're going to use Python or Java or PHP or something like that. JavaScript as well.
I also think it's that whole thing that Linux is, I'd rather learn Linux than Windows.
Yeah, me too. And I'd rather teach it.
The LAMP.
Yeah, I'd rather teach Linux than teach Windows. It just lasts longer. And, the knowledge that you gain on Linux, I think, lasts longer than the knowledge you gain on Windows.
And I just think it's so portable. If you understand Linux, I think I just remember now, you said in a previous interview, you shouldn't, because a lot of people make this mistake. They think they must just learn one language. And I think you said something along the lines, 5 or 6 languages is what you should learn, right?
Yes, absolutely. Absolutely. And it's at some point you need to learn a number of different languages because you have to relax when the syntax changes. You can't have gotten so much that you're sort of like a savant on the syntax. And if you see different syntax, that it throws you for a loop. The concepts in any programming language are the same. And until you've learned a bunch of programming languages, you're not operating in concepts. You're operating in syntax. And that's a key. And it's not easy to do. You can't just say, hey, this week we're going to stop talking about syntax. We're going to talk about concepts, blah, 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 2 hours later. And so you somehow know concepts. And the answer is no, you don't. Concepts come to you just with repeated work.
And I love that because, I think, and I mean, people can put all kinds of comments in, feel free to put comments below, but I have this gut feeling that if I know Linux, it's easy to pick up Windows. If I know C, it'll be easy to pick up other languages. Or multiple languages, it's easy to learn others. So I love what you've done, that it's open source rather than proprietary.
Right.
Dr. Chuck, the elephant in the room, a lot of young people have asked me this. It's pointless learning to code. It's pointless doing anything in tech, networking, coding, cybersecurity, whatever. AI is going to eat all of our jobs. What's your opinion about AI? And then perhaps later you can talk about ChatGPT and how that's changing coding, perhaps, or what's your opinion? So perhaps you can talk about AI and then come back to is ChatGPT making us dumb, something along those lines?
So I'll just start by saying that ChatGPT is not going to take all of our jobs. I mean, if ChatGPT was going to take all of our jobs, the previous 85 or 90 different technological breakthroughs, and ChatGPT is definitely a breakthrough, but the previous breakthroughs we're going to take our jobs, and they didn't, right? I mean, whenever we are talking to anything mechanical, whether it's ChatGPT, we get really upset really fast because they can't even take the simplest things, right? But so that it just taking our jobs is just such a foolish kind of dog whistle kind of way to think about it. But ChatGPT is amazing. ChatGPT is the closest thing we've seen up till now to true artificial intelligence. And there are some things that it does really well. A couple of quick stories, right? So last semester, which was September 2023, I called the first semester of ChatGPT. And we had sort of seen it in the spring and the April-May timeframe. And we spent all summer worrying about what was going to happen when September rolls around. And we got to face students with ChatGPT. And my colleagues, to a person, were not going to prohibit it and not going to fight it. I mean, it's dumb. That's like fighting search, or that's like, fighting text messages. I mean, it's just like, stop, find out a way to use it. So I will say that when I prepared for my fall September 2023 course, I put a lot of thought into how to deal with a ChatGPT menace, right? Meaning that I looked at my assessments, I looked at how I taught, and I'm like, I got to change. I got to change all this stuff, right? The biggest thing I did to fight ChatGPT is this. It's paper.
I can't see it clearly. You'll have to explain. Sorry, go on.
It's a piece of paper. So the biggest thing that I did to fight ChatGPT last semester was to use paper exams. And I'm like, ha!
Oh, that's interesting. Yeah.
I will give you a multiple choice question, A, B, C, D, and you're walking in with a pen and a paper and 2 pages of notes. And I don't care how you learned it, but you're not going to take my exam with ChatGPT next to you. You can do all my homework with ChatGPT next to you all you want, but you got to take my exam. And it turned out it was great. Students love the exam. I love the exam. It felt really good. I felt like I had built the best assessment that I had in the past 10 years of teaching. And then this semester comes along, and I look back on it, and I realized that the paper exam was a good idea. ChatGPT had nothing to do with it ultimately, right? ChatGPT was just a thing. My reaction was to do a paper exam. And so what it turned out was, it was a way for me to get the students' attention and give them responsibility for learning so that they couldn't use ChatGPT when they take the exam. And so I was like, okay, if that was good, I'm going to switch. And so this semester I'm using 3 exams. And literally I've stopped thinking about ChatGPT in my teaching completely, right? I mean, I'll use it someday. Maybe some company will make a cool ChatGPT that looks at all the videos I do and students can ask questions about something. And I've seen prototypes of this already where you say, how does time and a half for overtime to get calculated? And it finds the exact place in all my lectures that I talk about that. Students will love that, right? Because instead of having to watch all the lectures and remember what went where, they can ask a question about the lecture and be taken right to it. Does that make it so they don't have to learn anything? No, it actually makes it so it's easier to learn stuff because they're not looking at junk they don't want to look at. So it's going to help. It's going to help. And so ChatGPT made me think as a teacher what I'm doing right, what I'm doing wrong, how I could be better. And it was all, when it was all said and done, the things I did to kind of deal with ChatGPT made me a better teacher. And had almost, when it's all said and done, I just should have looked at myself and said, how can I teach better? How can I help my students learn better? And ChatGPT just happened to be like the scary thing that got me thinking about that. So that's one ChatGPT example. So another ChatGPT example had to do with, I had a bug in the Sakai project, which is 1 million lines of Java. And it has to do with double URL encoding. And so I was passing stuff back and forth between servers, and they got double URL encoded. And that's little percent signs on URLs. And it turns out that some firewalls are starting to break double URL encoding. They're starting to not pass double URL encoding. So I need to come up with a different way of passing this data back and forth. And I wanted to use a technology called base64, which turns it all into like hex numbers and digits and upper and lowercase letters. But base64 has like an equal sign and a couple of other weird characters that require double URL coding anyways. So I thought, well, how about this thing called base62, which is exactly the same thing that base64, except it doesn't have those characters that I didn't want in base64. And so I propped up ChatGPT because I couldn't find a base62 library. Base62 is a thing that's talked about, but there was no base62 library. So I popped up ChatGPT and I said, could you write me a Java-based base62 library? And it goes, sure. So I look at it and I'm like, yeah, that's pretty cool. That looks good. I look at this and I look at that. And I look at some of the code. And I'm like, okay, that looks pretty good. I'm like, could you write some Java doc for that? And it goes, sure. And so it writes the Java doc. Then I say, could you write a unit test for that? And it writes a unit test for it. And like, that's a cool unit test. It even seems like it has a sense of humor like I do when I write unit tests. And so I took this stuff and I threw it into a patch in Sakai as a fix for this bug. And it did fix the bug, right? Because I wasn't doing URL coding. I was doing this base62 encoding. So I went through code review, and the people reviewing it, they weren't entirely excited about my approach. They think I should use base64 because base62 is not common. And they look for a bunch of libraries. But I've kind of fought them on that. I'm like, I want to do this. But secretly, what I wanted to do is I wanted to take code that was written by ChatGPT and put it in this production software. I'm like, because I wanted to say, like, I want ChatGPT to be a partial author of my software. So I didn't want to look too close at it. I just wanted, because I tested out just fine, right?
That's the worry. That's the worry. Yeah.
Yeah.
Go on.
So they had argued with me, and I kind of beat them down in that argument. The code review people, I beat them down in the argument. So over their gentle suggestions, I put it in, and we handed it over to quality assurance. And 24 hours later, it breaks. And the quality assurance person ran something and it blew up, and I looked at the traceback and I could see exactly the line, and I looked at the line of code. I'm like, oh, I see why that broke. It's exactly why it broke. And so long story short, luckily the code review people had argued with me long enough about this thing that I kind of knew exactly what I was going to do if it didn't work out. So like in less than an hour, I had a better solution that used base 64 with like a hack on top of it. And it's like, we've done all this research because they'd argued with me about why I was using this thing. And I thought through all the alternatives, but I didn't want to do the alternatives. So it turned out, when it's all said and done, but ChatGPT had taken a base 64 algorithm and changed 2/3 of it to be like base 62. But it's really hard to change the other third. It turns out, having to do with the fact that it's not a power of 2, they just wrote a bad base 62. ChatGPT wrote a bad algorithm. And I look at it, I'm like, oh, that's exactly what a junior programmer would have done if you put a lot of pressure on them and said, you only have 1 hour, and I'm going to, based on when you write this code, if you're not done with this code in an hour, I'm not going to hire you. And so ChatGPT feels a tremendous pressure when asked to write a base 62 encoding algorithm. And so it reacted just like a junior developer, and it was very confident it was right. It was so confident that it was right. And I was so happy that it passed the unit test, which it did. It turns out the error was probabilistic and you had to have all kinds of weird patterns to happen. Eventually, the QA people did that. And so that says, wow, it's a junior programmer. It's prone to mistakes. And it has no sense that it's wrong. Zero sense that it's wrong. So I'm gonna start a series of podcasts where I use ChatGPT and kind of, because I've done a couple of other things where I've used it and I've learned it. I really enjoy it. So the other thing that, at my age, my friends have kids and they're going to college. And the question becomes, do you write your college essays using ChatGPT? And a friend of mine who also teaches at the University of Michigan has a son who's applying for college. And he was really afraid that his son would use ChatGPT or perhaps lose to someone who had written their essay in ChatGPT. So his strategy, which was really, I thought, brilliant. He's like, do something that ChatGPT would never conceive of doing, and then write about that thing that you did and write passionately about the thing that you did. So they bought an old car, like a 1976 Chevelle, and they started working on the car together. And his college essay was what he learned doing work on a 1976 Chevelle, getting dirty.
That's cool.
And so think about it. ChatGPT can't work on a 1976 Chevelle. So it can't talk about its experience doing that. So there are ways to write an essay that could never be written by artificial intelligence, because artificial intelligence can't experience life. It can talk about the cause of the Civil War, perhaps. So I went from a year ago being scared of ChatGPT to it's just another thing. And I want to learn how to use it and teach my students how to use it. And companies will come up with cool uses for it, and I will like that. But it's not going to stop anybody's need for becoming a programmer. And frankly, I think it increases the need to be a senior programmer, because I think ChatGPT has the same conceptual understanding of software development as junior programmers and will make the exact same mistakes junior programmers. And the way I found the mistakes of the code that I wrote, or I let ChatGPT write for me, was when myself and 2 other senior programmers were going over it, looking at where the flaws might be. And ChatGPT just couldn't do that, right? And so I'm not worried. I love ChatGPT. It's fine. I just snicker every time people, overestimate its capabilities.
So just to counter to that, once that essay is online, though, the next version of AI will have that story and could grab that, right?
Absolutely. Without a doubt. I mean, I think the key thing, though, is as long as it's a personal journey, it's difficult for you to say, pretend that I just bought a 1975 Chevelle and pretend that I worked on it and write a story about how I learned leadership and problem solving while I did that. I mean, it's hard to ask the question, even though you gave it that essay, right? And so I think it's difficult for ChatGPT to have a truly personal thing that comes out. I think it can describe things, but it can't really share feelings.
And so where do you see it going? Because ChatGPT is like V1 of a lot of what people have seen. But AI, the talk about exponential increase in intelligence and stuff, do you think, if I was a young person, I'm just framing this always the questions that I get on YouTube, is it worth me still getting into programming? Because I fear that ChatGPT perhaps can't do everything, but what about 5 years from today?
I think that question comes from people who are not yet programmers, imagining going to a beginning programmer position and thinking that a lot of the things that you do as a beginning programmer have become easier with ChatGPT, so they maybe won't need as many people. The problem is that your goal when learning to program is not just to become a beginning programmer, but to be a senior programmer. And that's where the creativity just comes in, right? When you're creatively solving a problem, I just don't think that ChatGPT can help you. I think ChatGPT can help you write a digital signature library, or it can help you parse JSON or whatever. And so those are things that we tend to do as junior programmers. But the concept of like, whoa, that's a really interesting problem. ChatGPT has no chance with those really interesting problems. So that for me is why it is that programmers should not just assume that they're going to go and become a junior programmer and that's the end of their career. And I also think that companies are going to want to take and invest and get their employees doing higher level thinking, which I think is just going to make the world a better place, right? If we just kind of have like a whole bunch of junior programmers, like a typing pool in a big room with banging on keyboards continuously, we're going to be better than that. We're going to be just like typewriters to word processors. And so you're going to have to move up a level. You're going to have to become creative and understand how computers really work. I think that it's going to be fine, but this is where talking about C programming for everybody, I think people who are currently working are going to need some kind of education that leads them out of the kind of the mechanical into the creative in terms of software development.
I love that. I mean, it's a great answer because I've seen so many examples of the AI, ChatGPT just being the poster child, creating code that's vulnerable. So it looks fine and it works, but it's not best practice. It's vulnerable. It's got issues. Like your example is great. Only a senior programmer would pick up those issues. I see it in networking. On the networking side, trying to get it to configure like BGP or OSPF or some kind of routing protocol, it kind of does it. But if you actually know what you're doing, you spot all the mistakes.
Yeah, it'll be helpful. But at the same time, there are things that are just going to do really well, and that is, I can't wait until there is a company or an open source project that can scan a corpus of an online course and give you a really rich index of that course. Because one of the problems that I have in scaling courses is that there is a conflict between personalization and scale, and people get stuck on the weirdest things, and then they drop out in large scale classes. And if I can come up with ways, and I really believe that they're just like got stuck on one thing, and then they got mad, and then they left, and then they gave up on their education. That's at least online like that, like on Coursera or just online or Free Code Camp or wherever you're going. It's just too easy to quit. But if I get something that can catch them at that moment and just give them a little bit of love, a little bit of encouragement, and I don't think that requires like super genius software. That just requires software that understands the material that I'm teaching from and can lead students to the right answers to the questions that they have.
Dr. Chuck, it sounds like you've been stuck, like creating this course. Do you actually manage to travel at all?
So one of the things that I've been holding off with C Programming for Everybody is doing the thing that I love to do, and that is go visit my students all over the world. And I've been there 70 times, and I think since COVID, I've only gone like 3 times. I just luckily ended up somewhere. So I'm picking up my my travel and going to visit students more and more. And I see that you go to conferences and people come up to you and talk, and I'm a little jealous of that. And that's really cool that you get to do that. And so I'm kind of kicking this off with a 1.5 long trip to India with Coursera, where we're going to go and visit. We're going to visit a number of universities that have adopted my Python course, and I'm going to try to convince them to also adopt the C course. And then we're going to go to a number of businesses that have adopted the Python course, and I'm going to try to convince them to do the C course for all the reasons that we've talked about, right? So in university, this is a great second course. But for businesses, I think it's even more important because you might have someone who took a C class 20 years ago, but they didn't know why they took a C class. They didn't know what the value of that C class was. My C class will give them the story, the backstory, and it'll teach them what they should have learned from that C class that they probably didn't back in the day when they were just taught a straight up C class. And so the other thing I'm hoping to do when I get to India is meet some of the employees that I've got from the master programmer, right? I mean, I've had a couple. I don't have enough scale to do all of them, but I'm going to meet some of the the students that have taken all my courses that I've hired. I know I get a lot of requests, but I don't have right now. I can't hire everybody who wants to come work for me, but I'm going to meet some of my people for the first time. And I'm going to go visit. I think I told you that we have a number of blind schools in India that use my Python course to try to teach blind students how to program. I think that, visually impaired and programming actually really work well. There's so many internal thoughts and concepts and constructs that we do as programmers, and I don't think you need to seeing is not as critical. And so the other thing that we've done is I've hired some blind folks to do accessibility testing on the Sakai project, and I'm going to meet some of those as well. So I kind of put myself in a cabin and finish this course. And now that I'm done with this course, I'm going to get back out in the real world and start meeting people again.
Dr. Chuck, I really want to thank you, for giving so much to the world. I mean, I think you said there's 3 million students on your Python course, right?
Yep.
So 3 million lives potentially impacted in a major way just through that one course. I really want to thank you, not trying to create some boot camp and become like a millionaire overnight by charging $20,000 or whatever stupid money people charge, but by giving to the world. And, I come from South Africa originally, and I've seen poverty. I know that people, they're very, very clever people, amazing people out there that if they just get the opportunity, can change their lives, change their family lives. And I really want to thank you, for giving back to the world.
Thanks for bringing that up. It reminds me of a YouTube comment that I just got in the last couple of weeks where I had posted a video and someone said, Dr. Chuck, thank you for all of the great classes. I took one of your classes a long time ago, and now I'm a teacher, and I'm teaching programming myself.
Love it.
And I'm like, oh, that's really cool. And then like a couple of days later, another person says, and by the way, I'm a student in that person's class, and I'm going to become a teacher too. And so
I love it.
It's just so joyful to see the positive. You just put something out there in the world, and you hope that it does good. And it is a joyful thing when it does.
Dr. Chuck, thanks so much. Really appreciate you spending so much time with me and sharing with the community. As always, big kudos to you for, giving to the world and, making this stuff available because people can change their lives through this. So thanks so much.
Thank you for doing what you do as well.